Hi everyone, welcome to the Physics 30 Unit 1 motion videos. In this video we're going to talk about speed versus velocity. So speed is defined as the rate at which someone or something is able to move or operate, and it is a scalar quantity, which means that it only has a magnitude or a size, and then it's got some units attached to it. So say for example, if you guys were to take maybe a ruler or a meter stick and you were to measure something, and we would get a scalar quantity, meaning our answer, say, might be 2 meters. We have the magnitude or size of 2 along with the units of meters. And we have a formula that we can use to find speed or represent speed. And so here we have V is equal to delta D over delta T, where V is speed, delta D is equal to your change in distance, and then delta T is equal to your change in time. So speed, as we said, so it's the rate at which someone is able to move. So here you're comparing the distance and the time. So velocity, on the other hand, is very similar to speed, except for the fact that it has a direction attached to it, attached to its units. So really it's just a comparison of your object's displacement, which is looking at the change in position, and then it compares it to the time for that object to move. So really here we're looking at the rate at which someone's able to move in terms of its displacement. So we're going to have a direction attached to its units. So say for example, if I were to walk in the north direction, maybe I walk a total of 5 meters, I would say that my total displacement would be 5 meters north. And if I were to do that, say in a total of maybe 5 seconds, I might say that I'm moving at a rate of 1 meter per second north. So you usually attach a direction along with those units. So it's a little bit different than speed. So with that said, velocity is a vector quantity, and so we can use it, represent it using a very similar formula, which is V with an arrow over it is equal to delta D with an arrow over it, divided by your change in time. So all of these arrows here represent vector quantities. So that's how you know the difference between your speed equation and your velocity equation. So notice how they're almost identical. Just the two of your units here have arrows over them, meaning that they have to have directions, which means that they are vector quantities. So V with an arrow over it is your velocity, not your speed. Delta D is your change in displacement. So here you'd have to have a direction attached to it. And then delta T is still the same, where it's your change in time. So time is a scalar quantity. You don't represent it using directions of a compass or moving forward or backwards. We just know that time just is as it is. So now we're going to practice our velocity equation using an example from our notes, which is number 1 from our notes section. So monarch butterflies migrate from eastern Canada to central Mexico, a resultant displacement of about 3,500 kilometers southwest in a time of about 91 days. So here we want to know what is the average velocity of a monarch butterfly in terms of kilometers per hour. So whenever I'm given a word problem, what I like to do first is I like to write down all my information. So our first little bit of information here that we have is this 3,500 kilometers southwest. And here they tell us this is the displacement. You can also tell it's your displacement because here we have a unit of measurement, like length in kilometers, and then it has a direction attached to it. So that's how we know it's displacement. So we have 3,500 kilometers, and that is southwest. Here we also have the time of 91 days, so that's delta T. Now before I move on to using my velocity equation, what I like to do is I like to do all my conversions first, because if you notice the question here, it asks for kilometers per hour, which we're given kilometers, but we're given a time of days. So this one here needs to be converted into hours. And so in order to convert your days into hours, I use a process called unit analysis, where I'm going to multiply by the change or the rate in terms of days and hours. So here I'm going to multiply by a fraction. And here I'm trying to get rid of the units of days. So I'm going to put days on the bottom. And I'm trying to introduce the units of hours. So I'm going to put hours up top. And then I'm going to say, well, how many hours are in one day? And there are 24 hours in one day. So here when I have 1 on the bottom of a fraction, this actually doesn't do anything because anything divided by 1 is just the number itself. So essentially what's happening here is I'm just going 91 times 24. And this one here will be 2,184 hours. One thing that I also like to do as I'm going through with my question is I will keep track of significant digits, which 91 days here has 2 significant digits, and I don't compare the 24 and the 1 day because these ones here we know these are true facts. These ones we didn't have to measure. We know that there's 24 hours in 1 day, so we don't take these types of numbers into account for sig figs. So here we have 2 significant digits for time. So I'm going to just underline my 1 here, so I know that that is my significant digit. Now that I'm working with proper units, now I'm going to go ahead and use my velocity equation, where I have velocity is equal to your change in displacement over that change in time. So my displacement here is 3,500 divided by 2,184. So you guys can go ahead and divide those two numbers, and what we'd find is that we would get 1.6. And then our units here are our displacements, that's kilometers per, and here our time was hours. So it's going to be 1.6 kilometers per hour. And then here we have the same direction as our change in displacement, so we can say that it's southwest. We also want to go back and just make sure we do a quick check on our sig figs. So with 3,500, here we have 2 sig figs. And then with the 2,184, we have 2 sig figs as well. So with multiplying and dividing, we go with the number, or I guess the least significant digit, which in this case here, they're both 2 sig figs. So here, we should go to 2 sig figs, and we're actually fine here. One last thing that we should do before we finish off this video is that this one here is a word problem. And with word problems, we always answer those with sentences. So we could say that the average velocity of the monarch butterfly is 1.6 kilometers per hour southwest. So once when you've written your sentence, you guys are all good to go. So just as a quick recap, make sure you guys are working with your proper units, and I would recommend doing them first. You can convert afterwards. I just find it a little bit easier to work with just the individual units themselves, like 91 days. And then just make sure that when you guys go ahead and do your math, make sure you guys are following proper significant digit rules. So with multiplication and division, they have their own set of rules compared to adding and subtracting. So be very careful with that. You can't just assume that since our questions only have 2 sig figs in the question, that our answer has to have, or can only have 2 sig figs. Most times that'll actually happen, work out where they have the same number of significant digits, but that doesn't always happen. So make sure you guys are keeping track of your sig figs throughout your whole question. So that is everything for this video. So if you guys have any questions, make sure to come see me in class, or you can text me on Remind 101. And thank you guys so much for watching.